James Webb Telescope's incredible new discovery left scientists in awe. Since the 1960s, NASA has sent numerous telescopes into orbit, but none have compared to the James Webb Space Telescope. No other observation station has gathered as much attention as the JWST, despite its astronomical cost and substantial delays. In contrast, a terrible discovery concerning the warp bubble that affects everything is already demonstrating the value of the new, powerful telescope. Welcome back to our channel. In today's video, we will discuss the Webb telescope's findings that have left scientists in awe. Don't forget to subscribe to our channel. Let's begin. We are all filled with the question of what a warp bubble is, what has been discovered, and should we be afraid? There are thousands of exoplanets, galaxies, black holes, and other things in the cosmos. Humans are a curious species that seeks to learn about their environment, both close and distant. However, since the universe is so enormous, distance is a barrier to space travel. The red planet is near us, given the expanse of the cosmos. On the other hand, volunteers for Elon Musk's colonization project must undergo more than 5 months of transit through the hazardous environment of outer space before reaching their new home planet. But what if you wish to go to Proxima b, Earth's nearest exoplanet? That is just a pipe dream. The exoplanet is 424 light-years distant from the Earth. A light-year is equivalent to 588 trillion miles. As a result, the closest exoplanet is around 25 trillion miles distant. That is not conceivable at 424 light-years. This will, however, not dampen our spirit of exploration since we have developed means to access distant celestial objects via space telescopes. If we can access these things, we may send intense eyes out to study them and reveal their secrets from afar. NASA has a lengthy track record of launching telescopes into space. The Hubble Space Telescope is one of the most well-known space telescopes orbiting the Earth and allowing scientists to focus it on various portions of the cosmos. On the other hand, NASA is the kind of organization that cannot stop deploying satellites and discovering applications for them in connection to the warp drive. There is a new sight in space that exceeds anything humans have deployed to see things in the cosmos far away from us. That is the James Webb Space Telescope, which has surpassed the Hubble Space Telescope as the most powerful space telescope. Thanks to the James Webb Space Telescope, scientists can now look farther back in time to examine how stars evolved close to the event that started the universe. It is 100 times more potent than the Hubble Space Telescope and can now see further back in time than the weakest star, within 350 million years of the Big Bang. If you're wondering how the JWST can see billions of years in the past, it's because light from distant stars is just now reaching us. After traveling for billions of years, this light will reveal what the stars were like billions of years ago from trillions of miles away, even though some of them may have perished. NASA has released the first batch of photos that will be used to illustrate the JWST's capabilities. The Carina Nebulae are two nebulae in bright zones in interstellar space. It is a billowy cloud of gas and dust roughly 7,600 light-years from Earth, home to several bright stars many times the size of our Sun. The images will also include the Stevens Quintet, a galaxy cluster located approximately a million light-years away. This galaxy group is remarkable because 4 of the 5 galaxies are locked in a type of dance with each other, their shapes twisted by each other's gravitational forces. Let us begin with what a warp bubble is. This reasonably complicated subject requires much math knowledge for a detailed understanding, but we will make do with a basic definition. A warp bubble is a bit of space contracted in the front and expanded in the back, theoretically pushing the protrusion and its contents forward at speeds exceeding the speed of light without ever violating the laws of physics. Because you travel in a walking bubble, you're not technically traveling faster than light. Assume that you can travel faster than the speed of light. Everything outside of your craft would accelerate, which means that the 3-hour excursion you took to a pleasant tropical planet could have equated to years on Earth. But if you want to travel faster than light while sticking to known physical laws, you should say goodbye to everything you had loved before setting out. However, warp bubbles avoid this issue because the space inside the bubble remains unchanged. Therefore, an hour spent traveling at warp speed means then just an hour passes for everyone else who is not now in your warp bubble. Fans of the Star Trek franchise are familiar with warp travel. The warp drive is a beautiful futuristic technology from the Star Trek universe, which has included television series and 13 feature films since its first episode in 1966. Characters in the series explore the universe in powerful and fast spaceships moving from planet to planet and communicating with an extraterrestrial crew. The torsion engine is the main attraction since the story would be implausible without it. The universe is bizarre, incomprehensible, and ridiculously vast. And even if you wished to visit the next star, the vast cosmic distances create an impossible barrier. Looking at the next star, Proxima Centauri 4.5 light-years distant, if you could travel at the speed of light, it would take you 4 or 5 years to reach the star. Light travels at full cosmic speed and functions as a universal speed limiter, so any other way takes longer. Even with the fastest space probe built, the long journey into the interstellar apse would take about 8,000 years. Thus, staying close to Earth and its nearby environment makes sense. Of course, the Star Trek crew didn't stay close to Earth because they discovered a solution that allows long-distance travel by shortening the time it takes. The torsion engine, which uses warp drive technology, accomplishes this by juggling space and time, making for excellent entertainment. Warp drive was destined to remain a fantasy until a scientist suddenly realized that such an engine was possible at the close of the past century. The warp engine is difficult to make. In reality, you can't find just aggressively curved space with average mass. It would help if you had an exotic matter with negative gravity. Alcubierre's warp drive function would by enclosing the spaceship in a bubble of flat spacetime and twisting space around that bubble to shorten distances. A warp drive would need either negative mass, a theorized type of matter, or a ring of negative energy density to work. But because physicists have never observed negative mass, we are left with negative energy as the only option. A warp drive would require massive masses to create an imbalance between particles and antiparticles to generate negative energy. This imbalance results in negative energy density. Cubille's warp drive would use this negative energy to create the space-time bubble. A significant quantity of matter would be needed to generate enough negative energy. Occupiers calculated that a 100-meter warp drive would take the mass of the whole observable cosmos. This looks to be an off-limits area. Warp bubbles seem to be a theoretical idea that will never be realized in reality. However, an entirely unrelated finding reignites interest in the notion and might prove to be a game changer. However, there is another source of optimism for warp drive supporters who want to see an actual warp drive created. And in the conventional mod of Discovery, the technology to build a workable warp drive may have been found by chance. Harold White is a DARPA-funded researcher working on a unique project. The Defense Advanced Research Projects Agency is an acronym for the Defense Advanced Research Projects Agency. He and his colleagues published their findings on the potential structure of energy trapped in a Casimir hollow at the Eagle Works Laboratory in Texas. According to the paper, White and his colleagues identified a micro-nanoscale system capable of predicting the distribution of negative energy density, which seems to be precisely what the Lucuba required to function. To put it another way, when they mistakenly performed a little experiment, White and his colleagues were studying a theory proposed by Dutch physicist Hendrik Casimir about how energy is dispersed across wavelengths. White explained that careful numerical analysis of the team's custom Casimir cavities assisted them in identifying a manufacturable nanomicrostructure that is predicted to generate a negative vacuum energy density, resulting in the manifestation of a real nanoscale warp bubble, not an analog. Still the real thing, implying the formation of a warp bubble structure. The experiment generated enough theoretical energy to realize Alcubierre's warp speed hypothesis. White was also aware of Alcubierre's theoretically sound idea for a warp drive that could travel faster than the speed of light without violating accepted physics principles. He was knowledgeable, however, of how the plan had been criticized for depending on theoretical materials and massive quantities of energy that were practically impossible to build in any meaningful form. White updated and modified Alcubierre's original metric into a conventional structure, considerably reducing the requirement for uncommon materials and the energy in the original design. The revised data resulted in an unofficial rebranding of the initial theoretical design, which is now more often known as the Alcubierre-White warp drive. It also offered experts and science fiction fans hope that a real-world warp drive may one day become a reality. White believes it is just a matter of time until he or another researcher constructs and tests his little warp vessel. White emphasizes that this does not indicate we are near to developing a fully operating warp drive, since much more research is required. There remains, however, a ray of optimism that humanity may one day be flying across the cosmos in a Star Trek-inspired warp bubble. That is all for this video. We will be back soon with another informative video. Don't forget to like and share this video. See you all soon.